I'm having fish tonight. Howdy, y'all. Calculus Cowboys here. Topic of discussion today is relative maxima. Let's begin. We use relative maxima to analyze functions over certain intervals and find values where the function is at its greatest value or lowest value. For example, when f of x equals x squared, we see a relative minimum occurring at x equals 0. When f of x equals x cubed, we notice that there is no relative minimum or maximum. F of x equals x cubed minus 3x plus 3, we see a relative maximum when x is negative 1 and a relative minimum when x is positive 1. Now if we notice, relative maxima or minima occur at points where the slope of the tangent line is equal to 0, as in these two cases. However, they also occur at critical points, like these examples. Critical points occur at points where the slope of the tangent line changes its sign. Now, in most scenarios, it'll be on a differentiable function like this one. At the point x sub 0, the slope of the tangent line is equal to 0. However, on this function, which at the point x sub 0 is not differentiable, so we can't take the slope of the tangent line, there still is a relative maximum. But we're just going to focus on cases where the function is differentiable on the interval. Now let's look at an example problem. Here we have the function f of x equals x cubed minus 3x plus 2. We'll ignore the graph and just use this for reference. As I mentioned earlier, all points on differentiable functions where there's a relative extrema occur where the slope of the tangent line is equal to 0. Now that's where the derivative comes in. If we have the original function, f of x equals x cubed minus 3x plus 2, just going to check that. Yeah, that's right. And we take its derivative, we can then set the derivative equal to 0 to find the x values at which the tangent line, the slope of the tangent line equals 0. So we'll take the derivative, f prime of x equals 3x squared minus 3. Now, like I said, that gives us the slope of the tangent line. Here we see the slope of the tangent line is equal to 0, if we follow the function, and here it's also equal to 0. So now to find those x values, the corresponding x values, we set this equal to 0. So when the slope of the tangent line equals 0, it's 3x squared minus 3. If we solve, we can factor out a 3. And then we see it's the difference of squares. So 0 equals 3x minus 1 times x plus 1. So the x values where the slope of the tangent line equals 0, so x equals positive 1, and x equals negative 1. If we look back to the graph, when x is negative 1, there is a relative maximum. When x is positive 1, there's a relative minimum. So our answers are correct. But if we don't have the graph and we want to figure out whether these points are relative maximum or minimum, we have the second derivative test. To do that test, first we find the second derivative. So if we go back, the first derivative, f prime of x equaled 3x squared minus 3. We'll start there. So f prime of x equals 3x squared minus 3. Now we take the derivative of that to find the second derivative. F double prime of x equals 6x. Now where we go from here is, we already found the x values where we have relative extrema. Those were 1 and negative 1. You take both of those values and plug them into the second derivative test. Plug them into the second derivative equation. So first we'll do f double prime of 1 equals 6. Now, f double prime of negative 1 equals negative 6. This might not seem to tell you anything, but that's where the test comes in. When the value that you get is positive, that means you have a relative minimum at that value of x. When the value that you get is negative, that means at that value of x, you have a relative maximum. So let's see. At 1, we have a positive value in the second derivative, so we should have a relative minimum. When x is 1, we have a relative minimum. Now for negative 1, we got a negative value for the second derivative, so we should have a relative maximum. When x is negative 1, we have a relative maximum. Those are the two main tests you use when calculating relative extrema. The first derivative test, you take the derivative of the function, set it equal to 0 to find the x points, the x values where we have relative extrema, and then to determine whether or not they're relative maximum or minimum values, we plug them into the second derivative and see whether they're positive or negative, which would then tell us whether they're maximum or minimum. That's how you calculate relative extrema. Thank you.